Bismillahirrahmanirrahim. Assalamu alaikum viewers, and good morning to everyone watching my videos with keen interest. I am very thankful to you for supporting me and appreciating me in this context. We are going to start today a new exercise, and we have already worked upon multiples, and now the turn has come to do some work on factors. What are the factors? Well, students, a factor is a number that divides exactly into another number. Got my point or not? I repeat the whole sentence once again, that a factor is a number that divides exactly into another number with no remainder. Okay? For example, 16. I take 16. Now, what are the factors of 16? 8, 2. And you see, if I divide 16 by 2 or vice versa, or by 8, no remainder is left behind. Now still there is one number which can be divisible further without having a remainder, and that is 4, 2. You see, 8 is when divided by 2, it gives us 8 complete and it does not have any remainder. Then again, we do have one more, and that is 4, and when divided by 2, it gives us 4 with no remainder. So my dear students, you see that I have broken 16 into prime numbers. I have broken 16 into prime numbers, and these are the factors of 16. If I multiply it backwards or forwards, let me do it backwards because I came from here. So I go back towards 16. 2 to the 4, 2 to the 4, and 4 to the 8, and 8 2 times is again 16. And there are two things to remember in factors, that one is always the factor of any number, and 16 is the largest factor of the number 16. This is, for example, this is the largest factor of this number, given number. That means the factor of any given number, the highest factor is the number itself. The smallest be the 1, the largest be the number itself. I hope you would have understood my point. And now I take few examples to proceed to the exercise. Now we have an example. Let us take a number 12, and we have to find the factors of number 12. So just as I told you, it is very simple. 6 and 2. Since we have got a prime number here, we leave it here and proceed it from the other number. And what we got is 3, 2, and 2. 3 to the 6 and 6 to the 12. Now there are other possibilities as well. For example, the number is again 12, we can have in this way also. So you see that 12 is broken up into 4 multiplied 3, 12, and 2 multiplied 2, 2 times 2 is 4, and 4 multiplied 3 is 12. Now I have broken 12 till I got a prime number. This is the point to be noted here. But if I say simply to write the factors of 12, so what is the proper procedure of this is I write F12, and what do I do here is I told you that 1 is always the factor and the number itself is a factor as well. So I write the both number like this, or I can write it here, or where do you want to write this? Now you see, my dear students, that 1 and the number itself are the factors of a given number. So rest of the factors are what we found from here. So we can write 2 over here, we can write 3 over here, we can write 4 over here, we can write 6 over here. So these are the total factors which are the factors of a given number, and the given number was 12. If you want to check each and every number that whether these factor gives us remainder with this given number, you can check it like this. Suppose I want to check it for 4. 4 and 4 3 times is 12. Therefore, you see that we have got no remainder. And similarly, for all the factors, there shouldn't be any remainder over here. And there is one question more. What are the pairs that can make the given number? What are the pair of factors which can make the given numbers back? Now, what are the pairs? You can see here that this is a pair. 3 multiplied 4 gives us 12, and 2 multiplied 6 again also gives us 12. 2 multiplied 6, 2 times 6 is 12, and there is one more, 1 and 12. 1 and 12. Now there are 3 pairs which can give the same number back to us. Is 3 times 4 is 12, 4 times 6 is 12, 1 times 12 is 12. Now a question arises here that 4 is also divisible, 6 is also divisible, 12 is also divisible. When we say pair, that means 2 only. Therefore, there must be 2 factors to give the given numbers back. So 3 and 4 is pair, 2 and 6 is pair, 1 and 12 is again a pair to give the 12 back to us. Question number 1. Let me start from part C. And the part C is 8. Number 8. We have to find the factors of number 8. So what we do is we write 8 here and keep on finding its factors. So these are the factors 2, 2, 2. The numbers are, how we write it? We write it F8 is equal to 1, the smallest, 2, 4, 8. We are not going to repeat these because we have already have taken 2 once. So these are the factors for F8, 1, 2, 4 and 8. And if you are asked that find the pairs also, then the pairs are 1 and 8, 2 and 4. And of course, if we just shift this 8 over here and 1 over here, that is again one factor, but we don't repeat the process. Therefore, there are only 2 factors which are the pairs of 8. 1 times 8 and 2 times 4 are the pairs. So this was very simple question. B. Find the factors of 11. So this is very simple, and you know that the 11 is a prime number and it cannot be divisible by any other number. So F11, B, 1 and 11. There are only 2 factors of 11. And the pairs also, 1 multiplied 11 is 11. Now let me take question number one interesting question I'm going to start is I. And I says that find the number of 57. Well, there is a trick that either to find that this number is a prime number or not. So what we do, we just put our calculator, this calculator, on, and what we do is we just simply plus the 2 digits over here. We just add the 2 digits over here. You see it has come 12. Now this 12 is divisible by 3 and divisible, this 12 is divisible by 3. So now you also see that the number ending on an odd number cannot be divisible by 2. So this cannot be divisible by 2, but it can be divisible by 3. So what we do here in rough work, we find the factors of 57 starting from 3. So what will be the outcome? 3 ones are 3 and we are left with 2. 7 comes from here and 3, 19, 27. So what are the factors? Now we write the factors of 57. Factors of 57s are 1 again, 3, 19 and 57. So my dear students, you see now this is a prime number, this is a prime number. Here what we got here is 1, 3, 19 and 57. So 19 is not further divisible, 3 is not further divisible. So these are the only 4 factors we have for 57. And we have also done one test of divisibility. So dear students, I have taken one more part from question number 1, and that is L and 132. So my dear students, if you find an even number at the end of any number and any given number, no matter how long it is from this side, it will be divisible by 2. So what I do here is I do some rough work and see whether it is divisible by 2 or not. 12 6 times 12, 2 6 times is 12, and again it comes as 12. So again it is divisible by 6. So what comes out here is 2. The first factor, don't miss the first factor, and the first factor is always number 1. Second factor is 2. Second factor is 2. Now what I told you about 3, let me check it for 3 as well. I told you just add all the digits. Just add all the digits. If you get any number which is divisible by 3, then the whole number will be divisible by 3. Now you see what we get here is 1 plus 3 is 4, and 4 plus 2 is 6, and 6 is divisible by 3. Therefore, this whole number is also divisible by 3. So what I do here is 4 times 12 and 4 times 12. So our next factor be 3. Since it is divisible by 3, it must have to be, since it is divisible by 2, let me check it whether or not it is divisible by 4. 4 3s are 12 and 4 3s are 12. So we got another factor, and that is 4. It is not divisible by 5. It is not divisible by, it is divisible by 6 also. 132, 6 2s are 12 and 6 2s are 12. So 6 is the next factor. Since I've got some factors over here, 1, 2, 3, 4, 6. The next factor is, you can see that what types of number we are getting. 44, 22, 66, 33. That means the number is also divisible by 11. And 11 1 times 11, 22, and 11 2 times 22. So I have come with two more factors, 11 and 12. So I write it here, 11, 12. I've got this factor, you can see here, when I divided it by 6, I got this factor also, so write this factor as well over here. When I divided it by 4, the pair was 33. So there are so many factors for this number. Now dear students, there are some more factors beyond 33, and we have written one factor over here. So let me write what we already have is 44 here. Now see whether or not there are any other factors for 132. Yes, we do have. here 66, and the last is 132 itself. So you see that this is the whole answer and whole factor, and this is a long train of factors which came out from 132. 1, 2, 3, 4, 6, 11, 12, 22, 33, 44, 66, and 132 itself. So my dear students, this was quite an interesting question. So dear students, let me proceed to the next part. Now question number 1, part M, and that is 160. So dear students, as I told you, for the last digit in the last part, similarly here you can see that we have a 0 over here. If you get 0 or 5 in the last of any number, then it is divisible by 5 or 10. And if only 0, you find 0 at the end of any number, then it is divisible by 5 and 2. Sometimes it is also divisible by 4, just this number is. But the test of divisibility for 4 are separate. So I can say that if you find 0 at the end, the number is divisible by 5, the number is also divisible by 2. Same is the case over here. So I can write here, first of all, 280. You see, it is divisible by 2. Now again 42, and again 22, and again 10, 2, and again 5, 2. So I have got a list of long 2's. I can also get factors from this as well. So what are the factors? Now for 160, F161 for the first factor, 2 as the second factor, and if I just add this number, this digit plus this digit plus this digit, if it is divisible by 3, then the whole number is divisible by 3. Since 160 is not divisible by 3, you see that this is not divisible by 3, so 3 is not the factor. So 4 is the factor. 5, as I told you, 5 must be the factor, and I have also written it over here. 5, 6 is not the factor, because when it is not divisible by 3, it will not be able to be divisible by 6 as well. 7, again 7 is not it is not divisible by 7, but it is divisible by 8. 2, 4 and 8. Then 10, and then now if I multiply this, 2 times 4, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and I have already got the 16, and 16 2 times is 32, and then we have another factor over here, that is 32. I am saying that there is also one factor, 5. If I go in this direction, 5 times 2 is 10. I have already written 5 times 2 times 2 is 20. So this is another factor. No matter if I have written uh, before 32 before 20, no matter. 5 times 8, 5 times 8 is 40. So we have another factor. So see how factors are developing, and 40 is also written over here. And one factor is 80, and the last factor is 160. In fact, these all factors come from this tree, factor tree. Two, you can see over here, here 2, and 2 times 2 is 4. We have written it here, and after that 5, 5 is written over here. 2 times 2 times 2 is 8. 2 times 5 is 10. 2 times 2 times 2 times 2 is 16. And all these 5 2's, 32, 20 is written over here, 40 is written over here, 80 is written over here, and 160 is written over here. So all the factors come from this factor tree. N 153. You see that this number is an odd number. Let me check it for, it cannot be, it is not divisible by 2. You see that at the end it is 3, and 3 is not divisible by 2. We don't have 0, we don't have 5. So what we do? I just check it for 3 plus plus. What is the outcome? 6 plus 3 is equal to 9. So 9 is divisible by 3. So that means 153 is divisible by 3. Let me check it in the rough work. 153, 3, 5 times 15 and 51 times. Now what the factors I got are 3 and 51. I just keep this 51 here and I write only 3 over here just to stay in ascending order. So what I write here is 153. 1 is the first factor as usual. 3 is the second factor, and I know that there is 51 also written over here. So if I add again 51, the digits of 51, it becomes 6. So 6 is also divisible by 3. Therefore 51 must be divisible by 3 again. So 3 ones times 3 and 21 7 times 21. You can also draw the table, the tree table over here, and the number was 153, and first was 1, 3 and 51, and then since we have got an a prime number over here, so this branch has been stopped over here and we continue with 51. Dear students, these are all the factors we can have from 153. But since there is, you can see that there is another factor which has emerged from here. 3 times 3 is 9. So what we write here is 9, and we can check it with 9 also. Somewhere here. 153, 1 times 9, and what comes out of here? 6, 63, and 67 is 63. The factors of 153 are now 1, 3, 9, 17, 51, 17, 51. You can also check it from here. 153, 17, 3, 9, and the number itself is 153. So these are the total factors of 153, 1, 3, 9, 17, 51, 153. If I continue with this exercise, it will be very lengthy. Have fun with this exercise. Question number 1, and just try my uh, thumb rules for test of divisibility that I told you from time to time between the questions. It's time to say goodbye. Have a nice day. Allah Hafiz.